We are in Precalculus. Today's date is Tuesday, March 12th. We are on geometric series here with Daisy and Rochelle. All right, so we've talked about this over and over and over again. So an arithmetic sequence. Give me an example.
2, 4, 6, 8.
2,
Who do we appreciate?
4, 6, 8. Arithmetic series.
2 plus 4 plus 6 plus 8.
You add them together. Plus 8. Geometric sequence. Give me an example of a geometric sequence.
1, 5, 10, 50, 250.
Ooh, we're getting fancy. 10.
Should we eat
Wait, 1, 5, 10?
Wait,
That doesn't
what?
work. 1, 5, 25 works. 1, 5, 25, 6, 25.
yeah.
Ooh.
Never mind.
And then geometric series.
Oh, so it's supposed to be 1, 2, 10, 50.
6, 25. All right, just multiplying by 5 each time.
Wait, is that a...
Do I have to have better handwriting?
No, it's okay.
Let me back up here.
6, 2, 5.
Plus 25 plus 625. I bet that 625 is much easier to see. All right, so we saw sigma notation in our warm-up today, and we're going to be using sigma notation again today. Sigma notation means add. Add them all up. Sum, sigma. That's the Greek letter for S for summing up numbers. So this is an example of an arithmetic series. Label it.
Wait a minute.
Arithmetic. What?
That's what I was going to say.
We don't have that.
What?
That's like the total opposite.
It's a total opposite. Did I print
Look
out
at
the
it.
wrong notes? Whoa. We are on 7-5 there, and we should be on 7. Okay. Hold the phone. So if this sigma notation represents arithmetic, then this represents. This one on the right represents.
Geometry.
It is indeed geometric.
I put him in my mouth too.
I was still.
And it looks really familiar too, right? Because our explicit formula for finding a sequence, we didn't do really series yet, but for finding a sequence, what we did was we did the starting value. So our starting value would be like 3, and then you do plus 2 times n minus 1. That was the explicit formula for finding a sequence for arithmetic, or an arithmetic sequence. And then our geometric sequence looked like this. It would be 3 times 2 to the power of n minus 1. So they look very familiar to finding the sequences for arithmetic and geometric sequences. The only difference now being we're putting the sigma in front of them, and there's no n minus 1. I don't have to do an n minus 1 because I can choose whatever problem to put in here, but you can see the relationship. We nod our heads, yes, we see the relationship. We're not trying to steal each other's food and be distracted. All right, very good.
I'm taking your food, I asked.
Nobody was
I asked with my eyes. When I plug in these values, you did this for the warm-up, so I can be very fast about it. I plug in 0 first. 2 times 0 is 0, plus 3 is 3, so the first value is 3. Then I go to the next index. The next index is 1. 1 times 2 is 2. 2 plus 3 is 5. You'll notice that you keep increasing by a factor of 2. 3, 5, 7, and then you go all the way to the last value, which is this value. 3 times 2 is 6, plus 3 is 9. There are 4 numbers in this sequence because you go from 0 to 3, including 0. So there are a total of 4 numbers. When I add, I don't know, I did commas there. I should be adding them. 3 plus 5 plus 7 plus 9. 3 plus 7 is 10. 10 plus 9 is 19. 19 plus 5 is 24. And there's our answer, 24. Geometric sequences, or sorry, series now. This is going to be, I'm plugging in 0 here. So 2 to the power of 0 is 1. 1 times 3 is 3. So it's going to be 3 plus, and then the common ratio is 2. So multiply by 2, and it's going to be 6. Multiply by 2, 12. Multiply by 2, 24. Again, there are a total of 4 numbers because it's from 0 to 3, including 0. When I add all of those together, I get, it's going to be 45. Thank you. And we already did that for the warm-up. That's why I can kind of breeze over that. All right, here's the problem. Uh-oh. I always say uh-oh to my son, so it's really weird saying it now. Uh-oh. The problem is, how are we going to do 301, because we're including 0, how are we going to do 301 terms of this? Just go really, really fast with the calculator? What's up, Rochelle?
This may be out of the subject, but have you seen the show SpongeBob?
Yes, I have.
You know that episode where it's like, it's funny the 24? 25.
I vaguely remember that, but it's been a long time.
What's the point?
Because it's 24.
Oh my god.
Okay.
I'm sorry.
All right. I'm glad that you have connections
I
with
left that out of
with certain numbers. Yeah, but that's the problem, right? We can't find 301 of these terms and do each of those added up. It will take forever.
I know, man.
So we need to find a quicker way. We'll come back to the problem. Let's find the solution of the problem. Finding a formula. If we find a formula, then we do it really fast. All right, this is the part where you guys kind of just have to nod your heads and try to follow the best that you can, okay? This is the proof. So A is the first term. R is the common ratio. N is the number of terms. S is the sum. That's the thing we're trying to solve for S using all
Like
these.
it's 300, right?
So we're summing 301 terms. All right, so let's do a general formula for S. S is equal to the sum of all these things. What's the first term? This is for you too. You literally have to read one of these. It's either S, N, R, A.
Oh, F.
The first term is
Sum of first letter.
is A.
Oh.
There we go. What's the second term? By the way, this is the first term. What's the second term?
Common ratio?
Yeah, you multiply the common ratio by the first term, right? You just keep multiplying by R. So it's going to be AR. To get from here to here, we just multiply by R to get from here to here. Are we following so far? And we did that to get the second term. All right, and then I'm going to add the third term, which is going to be what?
AR squared.
AR squared. And then AR cubed, and then AR to the fourth, AR to the fifth. You keep going and going and going. So I'm going to say going and going and going. You can do in a little ellipsis, a mathematical ellipsis, dot, dot, dot. Do your dot, dot, dot with me, girls. All right. What's the last term? And that's going to be hard.
AR to the n squared.
AR to the n squared?
To the n.
AR to the n. So we have a problem here. Do we end at n? Do we end at n plus 1? Do we end at n minus 1, n minus 2?
N minus 1.
Why n minus 1?
I don't know.
Good guess. But you need to explain why. Well, take a look here. The second term had a power of 1. The third term has a power of 2. This is the nth term because there are n terms. I defined that right here. There are n terms. We all agree that there are n terms? I said there are n terms, so this must be the nth term. Well, if this is the nth term, notice the pattern. The second term has a 1 power. The third term has a 2 power. Therefore, the nth term has a
300.
We're not thinking about this problem.
Oh.
We're just doing a general problem. So I always do what to get to this power? 2 to do what to get to 1? 2 plus 1 is 1?
Oh, 2 minus 1.
Oh, minus 1. Okay, so 2 minus 1 is 1.
So
3.
N
You just made me
minus
feel
1.
There it is. N minus
I
1.
was right.
Yeah, but you couldn't explain it. Yes, so you were right. It was n minus 1. Are we all okay why this ended at n minus 1?
Yeah.
Daisy, are you nodding your head for a different reason? Okay, but you do understand why it's n minus 1? You can nod your head in the up and down direction? Still no? Help her, Rochelle. Push her head forward.
Don't pet me.
What about the second to last term? The second to last term
I don't know.
right here should have been
ARN.
ARN
Minus 2.
minus 2. Yeah, and that's the n minus first term. Cool. So we have a general formula. That is S. We can all nod our heads. That is S for any sequence, so for any series. Okay, well, I'm going to do something a little bit tricky here. I'm going to multiply this S. Are we following?
Yeah, you're going to multiply the S.
We're going to multiply S by R.
Okay.
Why?
That is a great question. That is a great question, and the answer is because it works out. This is that weird thing with mathematical proofs. It's like, Why would you ever do that? And it's like, once you solve it and then you take a step back, you'd be like, wow, that was really smart. But you don't know until you get to the end of the proof. So for now, I'm going to handhold you and be like, we're going to do it, okay? I'm not telling you why until we see the very end of it. Once we take a step back, you'll understand. Right now, we're going to multiply by r. R times s. So far, so good? All right. So what is r times s? What's that first term going to be? What's that first term going to be?
AS? No, AR?
That first term is going to be AR. Because it was A, but I'm going to multiply it by R, so that first term is going to be AR.
Yeah.
Pay attention here. I'm not going to write it in my first slot.
You just. Do you.
I'm going to leave that slot empty.
Can
Why?
you give me
Because if I write AR underneath the other AR,
Mother.
you'll see a cool little pattern emerge.
Hey. Can you.
Hey, I can...
Wait! No, not this! I have a pen.
Oh.
So can you, like, white out or something?
Let's see. What can I throw at Daisy?
I
Really
Alright,
want to throw
shut
something
up.
at
I
Daisy.
don't even have any. I don't have any freaking pencils anymore. Everything's
All right.
so bad.
We are getting through this. That is AR to the first power. What is the second term? So this was the first term now. What is the second term?
They don't work.
AR squared.
Plus AR squared. That is the second term.
So the first one, AR minus 0.
Oh, so you're going to the last term, the nth term?
I'll try with the first one.
Oh, the first term right here?
Yeah.
That first term, well, the first term we already told. So the first term is right here. It's AR to the 1.
So what was I talking about then?
I think you were trying to go to the very end.
No, should I go from the beginning?
Okay,
Okay,
well,
never mind.
the beginning was AR. You got the beginning correct. At the very beginning. All right. What happens here to this AR to the n minus 2 term? When I multiply that by R, it turns into...
What?
If I multiply this term here by R, this second to last term...
Is it AR. Sorry.
I wonder if the mic picked that up. It's okay. It's pretty funny. I will tell us this.
I thought you were gonna throw up.
Because we're having too much fun here. This is math. You're not supposed to have fun. Because we shifted. So if we have the same n terms, if we count up all the terms, we have n terms. Notice that if we shifted this to the right, then my last term won't be underneath here. My last term should be shifted to the right here. Are we okay with that? So this is my last term. This is going to be my nth term. That nth term is what? Notice the pattern here. It's going to be AR to some power. Notice that this number and this number are the same. This number and this number are the same.
So it's N.
So it should be AR to the power of n. Daisy, are you okay with this?
Oh, my goodness.
Okay, what is the n minus first term?
ARN minus 1.
Yes, it is ARN minus 1. Okay, so far so good. We now have found two series. Our first series is just S. Our second series is R times S. We have those two series, and we made this special little thing where we shifted this bottom series to the right. So far so good. What I'm going to do now is I'm going to subtract this sequence from this, I keep saying sequence, this series from this series. I'm going to make a subtraction problem.
So it's just AR?
So I'm going to do this minus this. So I'm going to subtract this, subtract this, subtract this, subtract this. Are you okay with that?
No.
I'm just going to say we're going to do it, and we'll see what happens. When we subtract them, this is what happens. Draw a giant line. We have a giant line. All right, what do we have on the left-hand side? We have S something something. Tell me what I have. What do I have on the left-hand side of the...
So I only have R.
So I have S minus RS, right?
So it's just R.
You have to be careful because we don't have just R. We're just going to write out S minus RS. S minus RS. That's on the left-hand side. Haven't done anything special yet. This is the cool part. What's a minus 0?
A.
Yeah. All right, cool. A minus 0, that came down here to a. What's AR minus AR?
0.
0. Cross them out. What's
Yes.
AR to the 2 minus AR to the 2?
0.
What's blah, 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 blah? Those will all cancel out. What's AR to the power of n minus 1 minus AR to the n minus 1?
0.
Chunk, chunk. All of these are zeros, and at the very end I have what?
Just A or N.
Minus AR to the n.
So the total formula is S minus R S equals A minus AR N.
Yep, AR to the power of n. All right, but we're not done. We have simplified it incredibly. Like, we had like an infinite number of, well, maybe an infinite, like a ton of these terms. Now we only have 4 terms, 1, 2, 3, 4. But we still haven't solved for S. Remember, at the very beginning I said, we need to find this guy. We're almost there. You could probably do this on your own if you wanted to, but I'm going to guide you from here. Let's factor out an S. Factor out an S. What's left over when I factor out an S? What times S is S? That would have been S squared, but close. What times S is RS?
Should I say that again?
When I factor out an S from this term right here, what is left over?
R.
Is equal to A minus AR to the power of n. All right, I'm trying to solve for S. I want to get S by itself, capital S by itself. But unfortunately, I'm multiplying S by this 1 minus R term. Let's get rid of it. What's the opposite of multiplying by 1 minus R?
Divide.
Dividing. There it is. So divide both sides by 1 minus R. Divide both sides by 1 minus R. And we get our final beautiful formula, which is as follows in red. And I'm going to write it down here. Our final formula for our sum, I guess we can write it here too. We can write it twice. If you want to just write it down here, you can only write it once. Our sum is equal to, maybe I should do an arrow here. This turns into S is equal to A minus AR to the power of n, all of this over 1 minus R. Whew, done. You stayed with me. I think you followed most of those steps. So the trick was to multiply by R because we knew that if we factored it out here later, we can get S by itself. And by multiplying by R, we get all of these terms to cancel out. That's why we multiplied by R. When we look back at the problem, we're like, oh yeah, well, multiplying by R now actually works out pretty nicely and you can get the formula.
Honestly, this was just too much work to show us this one simple formula.
You would have just preferred me to just give you the formula?
Not gonna lie, yeah.
Daisy?
It's helpful to see like what from it,
Like how it came
like how it comes. Yeah.
I'm hoping that there's some general interest that I hit on both of you and something that I will never quiz you on. It's like, oh, that's interesting, and then we're going to move on. Can we just agree that it was interesting proof?
Yeah.
It's a pretty fun proof.
made us feel stupid.
Yeah.
I
you really
hope-
did.
I'm sorry that I made you feel stupid. But yeah, so if I go from 1 to n, how many terms do I have from 1 to n?
N minus 1. N.
N, just n, yep. So that means I have n terms here.
that's
My
right.
first term is a, my common ratio is r, and k is the index, so don't worry about him. So this thing is the same formula.
If K was equal to 0, would it be N plus 1?
Mm-hmm. Exactly. Yeah, that's really, yeah, if k is 0, it should be n plus 1 terms.
If it was 2, it would have been N minus 1.
Yep, exactly. Yeah, the fact that you understand that now is amazing. Not amazing to me because I know that you both are really smart, but I still didn't really understand series until I got to college. The fact that you just said that, going forwards and backwards and knowing the equivalent forms of that sigma notation is really beautiful. That's awesome. Yeah, so this is the same formula. It's just a minus a r to the power of n all divided by 1 minus r. And Rochelle has been in calculus. So Rochelle, what happens when I have a common ratio, and Daisy, I'm going to leave you just for a little bit, but I think you can probably still understand this. What happens if my ratio is something less than 1? So my ratio is less than 1, but it's still positive. It's still bigger than 0. So I'm going to give you an example. 1/4. Let's say that r is 1/4, and I'm going to assume that n, the number of terms, is going to go to infinity. This is calculus now because we're dealing with infinity. What happens when I take 1/4 to the power of infinity? Well, technically it's the limit as n goes to infinity, but what essentially happens when I take it to the power of infinity? What do you think is going to happen, Rochelle? What is this going to go to? What number is it going to approach?
Infinity.
I'll give you a hint. Well, I mean, if you're going to distribute, right? It's going to be distributing the infinity. It's 1 to the infinity over 4 to the infinity.
And there's more for infinity than 1 infinity, right?
Mm-hmm.
So it would be the bottom is more, so
Mm-hmm.
it's 0?
It's 0. Yeah. This thing evaluates to 0, which means if I have an infinite number of terms, anything between 0 and 1 is 0. Look what happens when you plug in 0 for n, or for r. That's 0, that's 0. You're left with,
A over 1.
oh yeah, sorry, only things to the power of n. So this whole thing goes to 0 because we had to the power of infinity. There's no infinity on the bottom. Whenever you take this thing as it goes to infinity, the answer is these 3 terms, a over 1 minus r. Isn't that crazy? When you have an infinite sequence or an infinite series, then you get 1 or a over 1 minus r. It's a very simple and really pretty formula dealing with calculus. That's my brief tangent, and we're going to come back to the normal lesson, returning back from our tangent. Let's try to apply the formula. This is a long lesson because we had so many tangents, but it's a fun lesson. Apply the formula. What are we going to do? See if you can even remember the formula from the other side. Try to do it from memory as much as possible.
First term is what k equals, right?
No, first term is this number out front. This is the first term. That would be my a. Oh, by the way, I should have mentioned this, and I feel like a horrible teacher for not mentioning it. I could have factored out an a for the equivalent form here. If I factor out an a, what's left over is 1 minus r to the n.
Could you have factored r either way as well?
What do you mean?
Because r, n, and r are almost the same thing. You would just have r on the top and 0 on the bottom for r.
That's not, yeah, that doesn't work because factoring only works when you have things that are being multiplied by each other. This is a minus sign, not a multiply sign, so you can't actually factor it. But it's a good idea. I wish there was a way to make it even simpler.
So
But
if r had like a power of 8, so then they can cancel out, right?
if r was a power of a, it would cancel
But if
out.
r had was multiplied by the power of 8.
So r to the 8.
Alright.
I think we'll see it more clearly once we start doing examples. All right, so this first term is a because it matches with our formula. See how these two things look the same? That's a, therefore that 2 is a. We're good? All right, well, how many n's do I have? Let's find n. How many terms do I have? Is it 49, 50, or 51? Daisy? It is indeed 51 because we include the 0 with there. So if I was from 1 to 50, the first term is 1, or the index of 1. The second term is 2, and you go all the way up to 50. So from 1 to 50 is 50, but now I'm going backwards, so I have to include 0 in addition, so I have 51. So n equals 51. What other things do we need in this formula? We have a, we have n, ooh, we need an r. How do we get an r? What is r in this?
Common ratio. So it's
Yes.
going to be 3.
Common ratio, and it is 3. I like the vocab word. R is the common ratio, and it is 3. We have a. We have r. This is the r.
Now we need 1.
And if you ever need to calculate n and you just want a formula, do this. N is equal to, here's your formula. I know you ladies love formulas. Top minus bottom. Plus 1. You knew it was coming. Plus 1. Because we always have to include the initial one. Including the beginning. R and A are in the formula for sigma notation, so there it is. All right, then we plug into our formula. I have the formula up there on the board. Tell me what to plug in.
So it would be 2 minus
Let's do the factored form, yeah?
1 minus 3 to the power of 51
Yep.
over 1 minus 3.
There it is. All right, so on my calculator, I have to do this, and you will get a gigantic number.
Oh, of course.
Yeah, I know, right? So let's do this. Should I do it on an actual calculator? I should. All right, let's drag you over here. So
Yeah.
I'm first going to do the inside of the parentheses. Here I go. 1 minus 3 to the power of, where is the, I haven't used this calculator forever. This power, to the power of 51 equals a very big number. What does this mean?
It means like there's a 10. Like all of that times it by 10 to the power of 24.
Yeah, it's basically like a -2 with 24 zeros after it. It's a giant negative number. So that is this inside the parentheses. I'm going to multiply that by 2 times 2. Boink. And now I have 24 zeros after the 4.
And then divided by -2.
And divide it by 2, make it negative. Bada bing, bada boom. There's our answer. Go ahead and write it down. And we're going to write it down in scientific notation. So if you don't know how to do that, watch closely. This is, so it's not the exact answer. So now we are going to approximate. So I do these little approximation symbol. 2.15, we'll round to like ish. We'll do like 3 decimal places. I know it's not technically decimals. But I'm going to go to 3 decimal places when it's in scientific notation. So 2.154. 2.154 times 10 to the power of 24. And that is our answer. I mean, technically I could have more decimals if I wanted to, but I think that's good. We'll just go 3 decimals for scientific notation. I wonder what con asks for. I don't remember. Oh, I think con is multiple choice, so you don't have to choose. I think. We'll see. All right, example 2. Oh, man. That was a really quick lesson. The lesson lasted the entire period. Okay, well, what do you girls want to do? You want to try the homework without doing the examples, or you want to just pick it up and do a lesson and a half tomorrow?
I don't mind anything.
Down for anything? All right, let's do a lesson and a half. We'll pick up tomorrow. No homework tonight. All right. We are back. Today is the 13th of March. We are on another day. Yesterday we left off on example 1. We are now on example 2. So this is a slightly different type of problem because now we know exactly how many terms. We don't have to do like start or top minus bottom plus 1. It just tells us, hey, n is equal to 60. Write it down. N is 60. We need to find all those variables though. So for this equation up here that we wrote down yesterday, we need to have a, we need to have r, we need to have n. Okay, we got n. Check it off. All right, we need to have r and a. Okay, I can find a. Can you girls see it? Where's a? Where's a? Where is it? Where's what?
A is 1.
A is 1. A is that first term. A is 1. N is this 60.
I got it right. I know. What'd you say?
Okay, now the hard part. Are you ready for the hard part? What is
Yeah.
R? What is the common ratio?
The common ratio is
Three
a
over two.
negative something.
Yes, it is.
-2.
Careful.
-4.
In order to do, because again, to get from the first term to the second term, I have to multiply by the common ratio. So what times 1 is -3 halves. So the common ratio is actually right here, -3 halves. All right, so we're using our formula. I'm pulling out the a. So I have 1. That's my a, and it's going to be times 1 minus this common ratio, which is -3 halves. Okay, parentheses matter here. This negative is inside the parentheses. It has to be inside the parentheses. To the power of 60. All of that over 1 minus a -3 halves. Whew.
Calculator time.
Calculator time. I'm literally just going to type that all into my online calculator, which is a little bit better. So I'm not going to do that 1 on the outside because that's kind of silly. 1 minus, it's going to be -3 halves to the power of, was it 60? It is 60. I guess it didn't really need all that. Divided by 1 plus, come on now, 1 plus 3 halves. And why am I getting, oh, it can be negative because it alternates between positive and negative. And this is one of those cases where it is negative because 1 minus 3 halves is negative 0.5. Adding 9 fourths is a positive. Subtracting 27 eighths is a negative. So it alternates between positive and negative. There's my answer. So again, I'm going to just use 3 decimal places. That's generally the way that we do it in AP Calculus anyway. So negative 1.471. So this is approximately equal to negative 1.471 times 10 to the power of 10. So negative 1 followed by 10 zeros. It's a really big number. And there is our final answer. That one's pretty easy peasy. Didn't require an extra formula. It did require you to find R. Here's a hard question. What if instead I had started at 9 fourths and got to 27 eighths, negative 27 eighths? How would you have found, I mean, the first term is easy, number of terms easy. How would you have found the common ratio?
Division.
How, yes, exactly.
It'd be, here, let me show you.
R is equal to,
Wait.
she's using her whiteboard. You take the second term, exactly.
Oh, it's the other way.
So yeah, you need a, so it should be the second term divided by the first term. Or the third term divided by the second term. Write it down in your notes. You might need this. Second divided by first will be the common ratio. Or third, and this is the same thing as the third divided by the second. Or the fourth divided by the third. This is all the common ratio. Make sure you have it in your notes. And we're finally on to our third example out of the 4. This one is what I consider to be the hardest question that I can ask for geometric series.
Oh.
All right, let's find A. What is A?
No.
1.
Oh, boom, Daisy got A. That means, Rochelle, you're going to find R.
R is 1.3.
R is 1 point. It just happens to be 1. Maybe I should stop making them start at 1. But 1.3 divided by 1 is indeed 1.3. You're using that formula up there. Or if I did 1.3 squared divided by 1.3, I still would have gotten 1.3. Now, the hard question is, how many items, how many terms do I have? What is n?
At 83.
You are correct. Explain it to us so we can understand.
Oh, me? Okay. So the first 1.3 is power 1, so that's the first term. And then 1, 2, 3, all the way up to 82. So far you have 82 terms. But you start at 1, which is the power, which is a 0th term. But that adds 1 more, so that's 83.
Got it? All right, just re-explain so that it picks it up on the camera, the microphone. Yeah, from 1 to 82, from this to this is 82. You just count them. First term, second term, third term. But this is not the first term, it's the second term, so I have to add on this additional 1 as if it was the 0th power. It's very similar to when I start here with 0. I don't know why it does that. When I start here to the 0th power, it's very similar to starting up here from k equals 0. It's adding on that additional number. So n is indeed equal to 83, which means we are ready for our formula. Our formula states do A, which is 1, times 1 minus the common ratio, which is 1.3. All of that to the power of 83. All divided by 1 minus 1.3. Plug it into our calculator. So we get 1 minus 1.3 to the power of 83. All of that divided by 1 minus 1.3. And you get 9.554. This is approximately equal to 9.554 times 10 to the 9th. To the 9th.
Oh! My God.
All right, I'll zoom in so that you can see it from...
All right, I am not blind anymore, Mr. Sindel.
Okay.
It's fine.
We're good? We got the answer?
Wait.
I'll wait. right. That means we are on to our final and fourth example. One of our easiest ones. I think this is so easy that I was even hesitant to put it in our notes. I'm so hesitant because what is A?
4.
A is 4. What is our R?
Negative 1.6.
It even tells us our R. What is our N?
It's 54.
It literally tells you all of the 3 things that you need. That's why I consider it to be so easy. Let's go ahead and do this without looking at the formula. Do it from memory. It's going to be 4 times blah, blah, blah. You should be doing it on your own. I'm going to be silent. I'll have the answer up here as you're working on it. The one hint I will give you is be careful with your parentheses. And I'm going to start entering this into my calculator. So it's going to be, I do have a 4 out front now. What's my ratio? Oh, I already messed up. Should stop pulling the pen as well. All right, and there is my answer. This is approximately equal to 1.620 times 10 to the 11th power. I should be boxing all of these answers. I don't know why I have not been.
I don't know why, but it's not giving me the answer.
It's not giving you the answer. Maybe I did something wrong. Did you make sure that your parentheses were around the negative?
I didn't do that. Ooh. I did the parentheses wrong.
All right, I'm going to go ahead and call it now. That is the end of our lesson, our very, very long lesson. Had so much fun. Go ahead and write your summaries now.